Hello friends, I am Shivam. Today we are going to discuss about dimension reduction analysis in data science. Introduction to dimension reduction. First, definition of dimension reduction. Dimension reduction is a technique that simplifies data analysis by reducing the number of variables considered, making complex data set more manageable. Benefits of dimension reduction. These techniques provide several advantages including simplifying model enhancing visualization, and improving algorithm efficiency while preserving essential information. Simplifies models. By focusing on fewer variables, dimension reduction help create simpler models that are easier to interpret and manage. Enhance visualization. Reducing dimension allow for better visualization of data pattern and trends, facilitating easier understanding and analysis. Improving algorithm efficiency. Fewer variable means faster computation, leading to improved performance of algorithm in processing and analyzing data. Maintaining significant information. Despite reducing dimension, these techniques ensure that the most informative features are retained, supporting effective analysis. Focus on informative features by concentrating on the most relevant variable. Dimension reduction enhance model performance and improvability, leading to better and analytical outcome. Understanding multicollinearity. Definition of multicollinearity. It refers to the situation in regression analysis where two or more independent variables are highly correlated, affecting the reliability of a coefficient estimated. Cause of it. Common cause include the inclusion of redundant variable data collection method that lead to a high coloration and model specification error. Effect of regression model. It can result in inflected standard errors, making it difficult to determine significance of predictor, leading to unreliable conclusion. Misleading statistical tests. High multicollinearity can distort statistical significance test, making variables appear significant when they are not, complicating decision making. Importance of identification. Identifying multicollinearity. It is essential to ensure accurate prediction and interpretation, aiding in a model refinement and enhancing analysis validity. Addressing multicollinearity. Techniques such as removing highly correlated variable, combining them, or using regularization method can help mitigate its effect. Detecting multicolority with variance inflection factor (VIF). Understanding VIF. Variance inflection factor measures the inflection of variance in regression coefficient due to multicollinearity. Significance of VIF. A VIF value greater than 5 or 10 indicates sufficient multicollinearity impacting the reliability of regression models. Calculating VIF in R. In R, use the car package example code. The library IFM model computes VIF for the linear model. Calculating VIF in Python. In Python, utilize the status model library example code from states model. States outliers influence import variance implementation factor. Identifying multicollinearity in dataset. Dataset features. The dataset includes features such as age, salary, and years of experience, which are critical for analysis. VIF method explanation. The variance implementation factor method is utilized to detect multicollinearity among the features, ensuring robust model performance. Purpose of VIF. The primary purpose of VIF is to identify the presence of multicollinearity which can skew the reliability of regression analysis. Tools for implementation. Both R and Python provide libraries to calculate wave making is accessible for data science and analysis. Implications of high VIF. The significantly high VIF Value for feature indicates potential multicolority with other feature, warranting further examination. Example of high VIF. For instance, if years of experience has been high VIF, it may indicate coloration with age, complicating the analysis. Data correction recommendation. True addresses multicolority considered data correction methods such as removing or combining colorated feature to improve model accuracy. Understanding principal component analysis (PCA). First, definition of PCA. Principal component analysis is a statistical method used to transform a dataset into a set of orthogonal components aiding in data analysis. Objective of PCA. The primary goal of PCS is to reduce the dimensionality of a larger dataset while maintaining as much as variability and information as possible. Mechanism of PCA. PCA identifies patterns with the data, allowing for a cleaner understanding of the relationship and distinctions among the points. Steps to perform PCA. First, standardize the data. Scale each variable to have a mean of 0 and a variance of 1, ensuring that the PCA results are not based by the original scales of the variable. Compute the covariance matrix. Calculate the covariance matrix to understand how the variable in the dataset vary together, which is essential for identifying relationship between them. Calculate e- given values and given vectors. Determine the given values and given vectors of the covariance matrix to find the principal components that capture the most variances in the data. Sort equivalent vectors. Order the equivalent vector based on their corresponding equivalence value to prioritize components that explain the most variances, facilitating effective dimensional reduction. Transform data. Project the originally data onto the new set of axes defined by the principal components, achieving dimensionality reducing while preserving significant feature. Performing PCA in R. Standardize the data. Beginning by standardize your dataset using the command data scale. Scale data. This ensure all variables contribute equally to the analysis. Perform PCA. Execute PCA using PCA result PRCOM. The center and the scale parameter help to optimize the PCA consumption. Display result. To evaluate the PCA result are use summary PCA result for detailed overview. Insights from PCA. PCA provides values insight into a variance explained by each principal component, aiding in understanding the underlying structure of the data. Performing PCA in Python. Introduction to PCA. Principal component analysis is a technique used for reducing the dimensionality of the data while preserving as much as variance as possible. Import libraries. Start by importing necessary libraries such as PCA from SQL decomposition and standard scales for data standardization. Standardized data. Use standard scale to standardize your data, ensuring that each feature contributes equally to analyze. Perform PCA. Initiate PCA with n components set of 2 to reduce the data to the principal components capturing the most variance. Visualize result. Utilize matplotlib to create a scatter plot of the two principal components, allowing visualization of the reduced dimension. Importance of visualization. Visualizing the reduced dimension helps us understanding the structure and relation within the data, enhancing interpretability. Principal components analysis of the iris data. There are five. Applications of PCA. Importance of standardization. Variance explained. Two-dimension visualization. Simplifying complex data. Importance of dimension reduction. Dimensional reduction techniques are essential for simplifying complex datasets, making analysis more manageable and insightful. Identifying multipolarity. Addressing multiple in crucial prevent. Applying PCA principal component analysis effectively. Streamlining datasets. These techniques help in filtering out noise, improving predictive models by focus on the most significant variables, enhancing interpretability. Reducing the dimension of the data makes it focus on critical aspects. Leveraging these methods allow data scientists unlock your data insight today. Join us to master dimension reduction techniques, identify multicolority, and apply PCA using R and Python to enhance your data analyzing skills. Thank you guys for watching this video.